theory to understand the concept of photoelectric effect. Wave theory means light is an electromagnetic wave consisting of electric and magnetic components, and we say that uh, propagation or spreading of electromagnetic waves means it is an energy distribution around a region, so that we can say that this wave theory can be used to explain a photoelectric effect, so that everyone so that we may try to explain this one. According to wave theory of light, free electrons absorb radiant energy continuously. The greater the intensity of radiation, the greater are the amplitude of electric and magnetic field. Consequently, the greater the intensity, the greater should be the energy absorbed by each electron. In this picture, the maximum kinetic energy of photoelectrons on the surface is then expected to increase with increase in intensity. Also, no matter what the frequency of radiation is, a sufficiently intense beam of radiation should be able to impart enough energy to the electrons so that they exceed the minimum energy needed to escape from the metal surface. A threshold frequency therefore should not exist. These expectations of wave theory directly contradict the observation of 1, 2, and 3 given at the end of this session. Further, we should note that in the wave picture, the absorption of energy by electron take place continuously over the entire wavefront of the radiation. Since a large number of electrons absorb energy, the energy absorbed per electron per unit of time turns out to be small. Explicit calculations estimate that it can take hours or make for a single electron to pick up sufficient energy to overcome the work function and come out of the metal. This conclusion is again in contradiction with the fourth statement of the photoelectric effect, so that we can say in all the aspect wave theory cannot be able to explain a photoelectric effect.